in this problem, we want to take the integral of the function x cos x. And since these two functions are totally two different functions, the nature of them are totally different. One of them is trig function, the other function is just a polynomial algebraic function. We can think of some methods like u substitution, which it's not useful here. And the other very useful method for this type of functions, this type of integrals, is integration by parts. And in integration by part, let me just write the equation for that. So we have integral of u times dv is equal to integral, it's equal to uv minus integral of v times du. The main key, the starting point to this solution integration by part is knowing which part of this is u and which part is dv. For example, you can choose this one be the u and the rest of that means x dx be dv, or you can choose x to be u and this part to be the dv part. So if you don't have any clue where to start, I mean how to choose one, and if you want to just guess, the best guess here would be using this mnemonic for the order of the functions in integration, which is ILATE or ILATE. I stands for the inverse of trig functions, L stands for log functions, A stands for algebraic function, T stands for trig functions, and E for exponential function. So what we have here is cos x, which is a trig function, and we have x, which is algebraic function. Because in this order, a came before t, a came earlier, we would choose a, or our algebraic term, as u. So in this case, x. So algebraic term that we have is x, and that would be the u, and the rest would be just dv, which means dv is equal to cos x dx. And to apply this this formula for the integration by parts, we need to know what v is as well as what du is. So to get the du, we take the derivative of that. So du is the derivative of x, which is just 1, and dx at the end. And for v, we already know what dv is, so we simply take the integral of that. So to find the v, we take the integral of cos x, which would be sine of x. Now that we have u, v, du, and dv, we can just plug them, substitute all of them into here. So overall, we have the integral of x, cosine of x dx. This is equal to u times v, which is x, times v, which is sine of x, minus another integral, which is v times du. V is sine of x, and du is dx. The idea is we start with an integral and we still have another integral, but the second integral is way easier. It's supposed to be a simpler integral. So just showing that here, this is u, this is the dv, and now we have u, v, and this is v, this is du. Now we need to just take the last integral, this integral, to answer the question. So integral of sine of x, we already know that is negative cos of x. So overall, the final answer would be, let's write it here, integral of x cosine of x dx is equal to this part, which is x sine x, minus this integral, which is negative cos x, negative cos of x. And instead of minus, we can write it as plus sign. And because it's an indefinite integral, it doesn't have any bounds here, we add a plus c at the end. The final answer to this would be x sine x plus cos x plus c.